Hello everyone and welcome to lesson 4 of my Permanent Way series, where I use city skylines to explain railway concepts in a reasonably bite-sized format-ish. So the last few lessons we were learning about what Permanent Way is, we were learning about straights and curves, we touched on transitions, and then we used all that information to create our first little railway. Now, that was just looking at the alignment of the railway in plan, if you like. So looking at in kind of 2D, so horizontal only. This time we're going to look at the vertical geometry. If you like, the Z-axis, the up and downy bit. In isolation, the vertical alignment of a railway is actually pretty simple. Constant increasing or decreasing grades are connected by hogging or sagging vertical curves. So hogging is where it's convex, sagging is where it's concave. Vertical curves are defined by a vertical radius or a parabolic curvature, depending on what button you click in your design software. Grades are defined by a gradient, so that can either be a percentage gradient or a 1 in value, so like 1 in 100. What I mean by that is, for every 100 meters forwards you go, you increase your elevation or decrease your elevation by 1 meter, so that's 1 in 100. Vertical alignment design gets fun and a bit tricky and complicated in a few different situations. Firstly, where you've got complex horizontal geometry. Secondly, where you've perhaps got multiple lines intersecting, or thirdly, where you've got physical obstructions that require a set vertical clearance. Good examples would include on the approaches to stations where you've got lots and lots of different lines meeting. You might have reversing horizontal curves where you want to keep the changes in horizontal geometry and changes in vertical geometry apart from each other. Perhaps where you've got a tunnel or something that gives limited vertical clearance above the train, adjacent to a station or maybe an underbridge. You might have switches and crossings where lines diverge and converge. We'll talk about those later. Different railway lines might be meeting each other from different elevations. You might have a grade-separated junction. And my favourite example of complex vertical geometry is where High Speed 1 in the UK intersects with the Dartford crossing. So it goes over the top of the road heading towards the tunnel under the Thames and underneath the road going up over to the Queen Elizabeth crossing. But just how steep can a railway get? Let's have a look at two gradients. First is a scale model made in City Skylines of the Lickey Incline, which is south of Birmingham in the UK, and it's the steepest sustained mainline railway incline in Britain, in the whole of Britain. The climb is a gradient of around about 1 in 40-ish. It's maybe a little bit steeper than that even. Maybe it's 2.65% gradient, which is pretty steep for a railway. And it's for a continuous distance of about 2 miles, so that's 3.2 kilometres. And this is what I've recreated here in City Skylines. As you can see, in City Skylines, it still looks pretty flat. Railways have to be flat. Freight trains actually just like they did in steam days, need a banking engine to get, so that's an extra locomotive that they stick on the back. They actually need that engine to get up this incline. It's very, very steep. Next to it, we have what looks like a much shallower gradient. Actually, this is a 1 in 100 gradient, so that's about a 1% grade. This is about as steep as you'd want to build a new bit of railway line. So freight trains can pretty much manage a 1 in 100 without too many problems, so long as you're not regularly stopping them entirely on the gradient and expecting them to start up again. In any case, you wouldn't want to build a railway with a sustained 1 in 100 grade for very long. We, as railway engineers, we much prefer a flatter railway than that. You can see that even a 1 in 100 gradient in City Skylines looks pretty flat, so frankly, when you're doing vertical geometry, you're not going to be paying attention to these rules of maximum and minimum gradients. And indeed, if you look at the steepest gradient that City Skylines will allow, you can see that it looks completely bonkers. While I've got these up, you might wonder what the flattest gradient we like to have on a railway is. Well, for new build, actually, we like to have about 1 in 500, so that's around about a 0.2% gradient. So we don't like our railways to be completely flat, and the reason for that is about drainage. If you've got a railway that's completely flat, it's very difficult to build a drainage system that suitably moves water from rain or whatever it happens to be off the railway. You've got drainage that runs parallel to the track. If you have a flat railway, your drainage has a certain minimum gradient to allow the water to flow, and you end up with your drainage deep beneath the railway line, which is difficult to install and impossible to maintain. To end tonight's video, I thought I'd show you what horizontal and vertical alignment design look like in real life, or rather, what it looks like on my screen when I'm doing it, seeing as it is my day job. Here's a very quick look at what I see when I'm doing horizontal alignment design. In this case, we've got an existing railway that we're realigning slightly to what we call applying slews to change the curvature to allow us to get a little bit more speed out of this railway. we look at the vertical alignment separately. So essentially you look at in plan, you do your horizontal design, and then you look at what we call a longitudinal section, a long section, when we're doing our vertical design. And this allows us to see the grades. We exaggerate that geometry so we can see it. You've seen how flat vertical geometry looks like in real life. In our computer-aided design software, we exaggerate that a lot so that we can tweak and play with those vertical grades and the vertical curves nice and clearly, and also make sure that we've tied them up, or rather done our best to avoid clashes with horizontal and vertical geometry. Within our design software, we then combine these two things, so the horizontal and the vertical alignments, as well as our cant alignment, which we've talked about before. Combination of those three things then gives us our 3D rail streams, which we output into drawings or some proprietary file or non-proprietary file that can be used by the tamping machine to automatically install the design, and then the installation team go out and make the railway the shape that it's supposed to be. And that's pretty much what track alignment design looks like. Thanks for watching this one. Next time we're going to be talking about bridges and tunnels, so putting a bit of what we've just talked about with vertical alignments into practice when you hit stuff that won't get out of the way. I look forward to seeing you then, and have a nice weekend. Cheerio!